Hey, fourth grade, how's it going? Mr. Joseph here, Monday, August 10th, 2020. Today we're going to be working in our prime math book, page 55, and students will be able to change mixed numbers to fractions, specifically improper fractions. So, let's get started right away. On page 55, you'll notice, boys and girls, that we were actually looking at the opposite of that from page 54. Okay, before we were taking improper fractions and changing them to mixed numbers. Now we're going to change mixed numbers to improper fractions. So let's go to page 55, letter A. On page 55, letter A, you'll see that we have the fraction 1 and 2/5. 1 and 2/5 can be easily separated into a mixed number by adding the whole number and the fraction. In other words, what we can do is we can separate 1 into 5/5 and 2/5. Let me show you that below. 5/5 equals 1 because we have 5 equal parts shaded and represented inside of the one whole pizza, for example. Okay? And if we have 2/5, can represent that as well. And all we have to do to figure out the answer for our improper fraction is add our whole plus our fraction. Again, our whole plus our fraction. So 5 plus 2 equals 7, and our fifths stay the same. Our denominator doesn't change. So our answer is 7/5. All right, let's do letter B. I know that 1 and 1/4 can be separated out into 1 and 1/4. So since we can separate that out, we can also separate 1 into 4 equal parts. 1, 2, 3, 4 equal parts. In other words, this is equal to 4/4. Any number over itself that isn't 0 equals 1. Now I'm going to add my part. We have 1/4. So what is 4/4 plus 1/4? 4 plus 1 is 5. And our fourths stay the same. 5/4 is our answer. Let's go on to the next problem. Letter C. Before we do that, Mr. Joseph has a meme for you. The dinosaur says, if 100 over 100 is full, is 0 over 0 considered full? Well, of course, we know it's not. 0 over 0 cannot equal 1, but any number over itself always equals 1. Letter C says 2 and 6/7. How do we change that to an improper fraction? Well, we can separate 2 into 1 plus 1. And 1 we can separate into 7/7, as shown right here in the drawing. Again, 1 can be separated into 7/7, as shown here in the drawing. And then we just add our 6/7. So what we're basically doing is adding the numerators, 7 plus 7 plus 6. Well, I know that 6 plus 6 plus 6 equals 18. And if we add 2 more, that's going to equal 20. So my final answer is 20/7. In other words, 2 and 6/7 equals 20/7. The same number, exactly the same. Letter D says 2 and 1/10. Well, I know that 2 equals 1 plus 1, and I know that 1 can be separated out into 10/10. I know that I'm working with tenths because I looked at my other fraction right over here. Another 1 also equals 10 tenths, which can be represented here inside of our drawing. I am coloring 10 of the 10 pieces. In other words, if we have 10 people and 10 pieces of pizza, we only need to order 1 full pizza. But if we have 2 pizzas and 20 people, that means that we can separate these 2 pizzas into groups of 10, and 20 people are going to be able to eat the 2 pizzas. In other words, 20 tenths equals 2. But I'm not quite finished. I need to add 20 tenths plus 1 tenth. What's 20 plus 1? 20 plus 1 is 21. So our final answer is 21 tenths. All right, boys and girls, let's go to letter E. Letter E says that we're supposed to find out what is 3 1/6 as an improper fraction. Well, 3 1/6 is the same thing as 1 plus 1 plus 1 plus 1/6. So we can represent 3 by saying 1 plus 1 plus 1. In other words, we can change this first one into 3 over 3 if we wanted to. But I'm not going to do it like that. I'm going to look at my denominator, which is 6. So I'm going to change, instead of 3 over 3, I'm going to change that to 6 over 6 plus 6 over 6 plus 6 over 6. In other words, I have 3 wholes represented here. Now I'm not going to forget to add my extra fraction. I know that 6 plus 6 plus 6 equals 18. And 18 plus 1 equals 19. So my final answer is 19, and my denominator stays the same. 19/6 is my improper fraction, which again is the same as 3 1/6. Letter F says 3 1/3. Well, 3 can be equal to 3/3 plus 3/3 plus 3/3, and then we add our last fraction, 1/3. Now that they're all the same denominator, we can easily add all the numerators. 3 plus 3 plus 3 is 9, plus 1 more equals 10. 10/3 is our improper fraction, which is the same as 3 1/3. All right, boys and girls, I think that you're understanding most of these problems pretty well. Let's go to the last couple of problems on this page. Before we do that, I'd like to show you a little meme. It says 4 out of 3 people have trouble with fractions. This is funny because if 4 out of 3 people have trouble with fractions, that means that most people have trouble with fractions, even more people than what is represented. Let's go to letter G. Letter G says 2 1/2. I know that 2 1/2 can easily be converted to an improper fraction if we take 2 and we separate it out into 2 separate fractions. 2 halves plus 2 halves equals 2, plus 1 more half equals 5 halves. Letter H says 4 3/5. Well, I know that instead of 4, I'm going to represent my whole numbers as fractions, which could be 5 over 5 plus 5 over 5 plus 5 over 5 plus 5 over 5. You'll notice I wrote that 4 times because we have 4 whole numbers. Now I'm going to add my last fraction, 3/5. Since they're all the same denominator, I can easily add them. 5 plus 5 plus 5 plus 5 is the same as 5 times 4, which is 20, plus 3 is 23. 23/5 is my improper fraction, which is the same as 4 3/5. All right, I think that these problems, since they all have the same procedure, are pretty simple. We didn't get to this problem today, but I'm going to do it on the board just so that you can understand, because we don't have class next week, okay? This last problem, letter I and J, we didn't get to, but go ahead and pause the video so you can do them on your own, and then check your answers at the end. All right, hopefully you paused the video. Let's check our answers for letter I on page 55. I can change 1 to 9/9, and then just add my second fraction, 4/9. What's 4 plus 9? 13. So 13/9 is my improper fraction for 1 4/9. Last problem, 2 5/12. Well, since I'm working with 12ths, I'm going to change 2 right away to 12/12 plus 12/12. Not forgetting to add my second fraction, 5/12. I just go straight across, 12 plus 12 plus 5. Well, you know, 12 plus 12 is 24, plus 5 is 29. So our answer should be 29/12, which again is the same as 2 5/12. All right, what we're going to do, boys and girls, is I'm just going to show you a couple of games that you can play. This splashlearn.com is really cool. You can equate the different fractions, see which one's bigger, and then also try to guess the number on the top for those equivalent fractions that we've learned a couple of weeks ago. I'll put the link inside of the video. This one's also kind of cool. It's another Splash Math game. You can figure out which fractions are greater than 1, and there's also lots of other types of games that you can play on this website. The ones that I'm going to show you today are converting fractions with gems. It's kind of a neat game. You do need to sign up, but if you try to click on the game, for example, you're going to have to sign up. But as you can see, you're trying to equate mixed numbers to improper fractions, and all you have to do is click on the numbers below. So it's relatively simple. This one's also pretty simple. It says just an improper fraction that a mixed number that you have to change to an improper fraction. 6 1/2. Well, we know that 6 is the same as 2 halves times 6, which is 12 halves, plus 1/2, so 12 plus 1 is 13, so 13 halves. All right, next question. 8 7/10. Well, I know 8 is the same thing as 10/10 times 8, and 10 times 8 is 80. 80 plus 7 is 87. So 87/10 is my answer. Next question. 10 4/9. Well, I'm going to change 10 as my whole number into 9/9 times 10. 9 times 10 is 90, and 90 plus 4 is 94. Our denominator stays the same, so 94/9 is our answer. I'll put the link of this game inside of the video notes. The last game that you can play, if you'd like, is converting to a mixed number. For example, you have to guess it. So 5/27, 5 goes into 27, 5 times, so 5 is my whole number. And then 27 minus 25 is 2. So 5 2/5. Let's see if we're correct. Ooh, we got it. Nice job. Next question. 52/5. All right. I know that 5 goes into 52 10 times, and we're left over with 2. So 10 and 2/5 must be my answer. Let's check. We got it. This is going to be a little bit more difficult for those 4th graders that need a bit of a challenge, but still, I'll put this in the video notes. And once again, boys and girls, next week we do not have class. So we will see you on August 24th. Have a good week.